Hey everybody, this is our limits and derivatives video 5, and it's actually the first video that we're going to be introducing derivatives. So make sure you have your class note sheet with you and we'll get started. Alright, so this first part is really just going to be reminding you the direction that we're headed with slope, so you can kind of see that. I use the word slope, yes. So if I had a curve anywhere on here, well, if I had a straight line, okay, my slope, I could pick any 2 points, let's say A and B. Alright, now A corresponds to this value and B corresponds to this value. So if I have the height of that, it's actually f of A, and that means that it's the y value that's associated with A, and then this one would be maybe my f of B. Okay, so I actually get these ordered pairs like this, and if I wanted to find the slope between those two ordered pairs, or the slope of the line, then I would do f of B minus f of A. Now those are my y values, that's all that means. I don't need that extra line there, I'm sorry. So it's just my y values, and then I would subtract my x values, okay? So that's, again, y minus y and x minus x. So here's just a different way of looking at it if I were to not tell you what x and y are. Alright, so what if I give you a picture that it isn't a straight line? For example, a curve, and I say, let's exaggerate that curve a little more on mine. I want to make it a little more curvy. Okay, and I said, oh, I want to know what the slope is from here to here. You say, well, it's not a straight line, I can't find the slope. Well, what we're going to be working on here is we're going to actually be interpreting that slope, because there is a change. A slope is a rate of change, and there is a change between those locations. So what we can do is, if again I call this A and we call this one B, then this is my f of A and this is my f of B. So we can actually find the slope of the line that passes between those 2 points. So just the idea of slope that's not on a straight line, or straight line, this kind of curved picture, that is where we're headed today. Okay, so now on to the note sheet. You've got this picture at the top. It's very similar to the one I just drew, except it doesn't use A's and B's. It starts with, let's call this x here, and let's call this x plus h. Well, what does h really represent? It represents the horizontal distance that we moved. So h is just a horizontal change. Well, if I move in a horizontal way, it looks like my function changed vertically. So that's how we get f of x plus h. So I'm going to actually name these two ordered pairs as x comma f of x, and this one as x plus h comma f of x plus h, just like we did the f a comma f of a and b comma f of b. So if we apply this formula, which we wrote on the previous page, which is merely slope, to these ordered pairs, we get this. I get the y value minus the other y value and the x value minus the other x value. Okay, now what that simplifies to in the denominator is x plus h minus x. The x's cancel and I just get h. Now don't worry, we're going to be using this in a different way in a moment. I'm kind of tying a bunch of things together, but merely I'm looking for a slope. Now, very specifically, I want to eventually move this h value in so that I'm no longer looking at something so far away, but I keep moving it in and I keep moving this other point in, okay, making my h value 0. I want no horizontal change. I want these 2 points to be so close they're neighbors. Kind of has the idea of limits as they approach each other. I want no space between them. That's the idea. So another little piece of this would be to evaluate f of x plus h. So that means that in place of x, sorry, use the back of your note sheet for this, but in place of x, I'm going to use x plus h. So I will replace the x with an x plus h, and then we will simplify. Now we're practicing it here because it's going to make it easier on the next one. So I'm going to have 7x plus 7h minus 3. Since there are no like terms to combine, that's it. The next one, find f of x plus h. For this, I will replace x plus h in both x value locations, in here and in here, and then we will expand to simplify. Now when I expand this, I do not just get x squared plus h squared because I have to multiply it all the way out. Okay, and then I will distribute that 5x, or that negative 5. And next I'm going to collect like terms. The only like terms I have are x plus h, or xh, giving me x squared plus 2xh plus h squared minus 5x minus 5h. Okay. Let's practice one more together. I'm going to replace this inside of both of these x values. 2 parentheses x plus h squared plus 3 parentheses x plus h plus 1. Since we already expanded this above, I know it's going to reduce to x squared plus 2xh plus h squared. I still have to multiply it by 2. And that's what we'll do here. Plus 4xh plus 2h squared. Distribute the 3. And I have absolutely no like terms, so this is f of x plus h. That's what this entire line is. Now let's get down to business. Here we go. The definition of a derivative. The derivative of a function at x is denoted f prime of x. F prime of x, or the first derivative. And we are going to be writing this entire thing out because we're looking for the h value to become a 0. I can't use direct substitution because I would have a 0 in the denominator. So we must use some simplification to do this. Here we go. Everything I write, you have to write. I'm not going to write anything that's unnecessary. Everything is important that I write, and it's important that you write it the same way that I write it. So please be very careful as we do this. I'm going to start every single time by writing the definition of the derivative. That is, f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h. Now I will start substituting. Just as we did on the previous page, I'm going to take this f of x plus h, I'm going to put the x plus h inside. I will write the limit as h approaches 0 every single time. And now I'm going to do my replacement. That is f of x plus h. I still have to do minus the original function. All over h. In my next step, I will distribute both the 4 and the negative 1. The limit, every single time, as h approaches 0, I'm distributing 4x plus 4h plus 2 minus 4x minus 2 all over h. Let's start to simplify. The limit as h approaches 0. The reason I have to repeat the limit is because I haven't used the limit yet. So now I will have, my 4x's cancel and my 2's cancel, so all I'm left with is 4h over h. Now, I still can't use direct substitution because if I put a 0 in the denominator, we've got a problem. Luckily, we're able to remove the problem. We can cancel out the h's. So I have the limit as h approaches 0 of 4. Now I can use direct substitution, except we don't have anywhere to put the h, the 0. So we remember that when we have the limit of a constant, the answer is the constant. So we're like, yay, we finished. Well, what does this mean? This means that for f of x, my first derivative is 4. If you're lost, it's okay. We're going to keep doing some more of these. The next one. Start with the definition of the derivative. Whoa. Start with the definition of the derivative. The limit of f of x plus h minus f of x all over h as h goes to 0. Start your substitution. The limit. Here I'm going to be placing my x plus h in 2 locations. X plus h squared plus 3 times x plus h. Don't forget, you have to subtract the original function. I'm going to highlight that. So the part we just did here matches this part. The next part we're going to do is the minus the original function. Okay? So here I'm going to do minus x squared plus 3x. So those are the 2 parts that match, all over h. Continue to simplify. The limit as h goes to 0. I'm going to expand this, which we did twice before. X squared plus 2xh plus h squared. Distribute the 3 plus 3x plus 3h minus, distribute the negative, x squared minus 3x all over h. In the next step, I will cancel out in the like terms that are in the numerator, so I'm going to start reducing. X squareds, 3x's. The limit as h goes to 0 of 2xh plus h squared plus 3h all over h. I can't use direct substitution because I have a 0 in the denominator, so I'm able to factor out an h in the numerator. The limit as h goes to 0 of h parentheses 2x plus h plus 3 all over h. Now I see my h's cancel. The limit as h goes to 0 of 2x plus h plus 3. Now direct substitution works. When I use direct substitution, I get 2x plus 3. My final answer, I ran out of room, is f prime of x equals 2x plus 3. Alright, I'm going to try number 3 with you on the next page, and then I'm going to let you do number 4 on your own. Once again, we're going to start with f prime of x equals the limit as h goes to 0, f of x plus h minus f of x all over h. I will start my substitution. The limit as h goes to 0, I'm going to put in the f of x, the h plus x plus h inside of here, which gives me 5 times x plus h squared. Now I'm going to subtract the original, which is just minus 5x squared, all over h. The limit as h goes to 0 of 5 parentheses, I'm going to expand x plus h squared, x squared, plus 2xh plus h squared, minus the original, all over h. Okay, this one's going to clean up a little faster. I'm going to distribute the 5 next. The limit as h goes to 0, 5x squared plus 10xh plus 5h squared minus 5x squared all over h. In the next step, my 5x squareds will cancel. The limit as h goes to 0 of 10xh plus 5h squared all over h. I'm at the point where I say, I can't put in the h equals 0, so I have to factor out the h in the numerator. H comes out 10x plus 5h all over h. My h's cancel. The limit as h goes to 0 of 10x plus 5h. Now I can substitute in the 0 because I have no denominator to be concerned about. which means I have the limit, we have, if I put in a 0 here, I just get a 10x. My answer is f prime of x equals 10x. My derivative equals 10x. I'd like you to try number 4. I'm not telling you that you have to write this because I'm being mean. It's part of the process. You're in a 400 level math class. We're going to write it all. If you choose not to, you're going to get 0 points for a problem such as this. It's very important. It's the notation. It's mathematics. Please write every step. Alright, before you skip this, okay, please make sure you understand that what we're really looking here for is the idea of slope. Okay, we'll expand more on the picture of this problem tomorrow. The next thing you have to do is make sure that you use the correct notation. We will always start with the definition of derivative, which is the first derivative equals the limit as h approaches 0 of f of x plus h minus f of x all over h. This is something you're going to have to memorize and you're going to have to use. For every single step, you must begin with the limit as h approaches 0. The equal sign is over here. It's not in between. Then you'll use your substitution and you'll continue. And when you get done, your final answer is written f prime of x equals, and that's where you write your answer. Alright, talk to you guys soon.